to today's webinar. Today we have Kai Moncino from FLIR, Teledyne FLIR, and he is the Global Business Development Manager for Securities for Teledyne FLIR. And with that, I will hand it over to Kai.
Thank you, Gina. That was a good correction there that you caught yourself with the Teledyne FLIR, because, and in fact, you know, I am delinquent in having actually changed the PowerPoint templates. So FLIR was just acquired about a month ago by a company called Teledyne, and we're now called Teledyne FLIR. So that is the new name of the company. All the existing organization of the company really just rolled up underneath Teledyne, so nothing really changes for our customers in the day-to-day business of how you interact with us, but it is a new name. So thanks for noticing that. So I'll be talking today about security solutions for the oil and gas industry. FLIR has been doing security for several decades, and really our focus is on critical infrastructure markets, the oil and gas industry being one of them. And there are some nuances to our security solutions that are just different than general security applications, and I'll touch on those throughout the presentation. But before I go into our capabilities and so forth, I'd like to just kind of frame out really why you should even care about security solutions and what they can do for you, in addition to the obvious ones of, you know, preventing and investigating crimes. So first off, you obviously want a security solution to protect your assets. There are both real-time and forensic aspects to that. So obviously, if something happens, you want to be able to go back and review footage and potentially press charges and have evidentiary video to show in a court of law. But there's also the real-time aspect where you can get alarms from your security solution while things are happening, so that you can respond and potentially prevent those, incidents. In many cases, insurance companies will work with you to lower your rates if you have a sufficiently, sophisticated security solution, because obviously you're preventing events and you have evidence of those events once they happen. So you can really get a tangible return on investment with a security solution by having lower insurance rates. An automated security solution is a great complement to on-site security staff. So, you're not necessarily replacing security guards and operators with an automated security solution, but you can keep them safe. You can help them, provide them with good information about what the threat might be, and keep them out of harm's way. So say you have an intruder with a weapon, the security operator that's watching the video can alert the responding security staff that they should, maintain a safe distance and alert the proper authorities. So these systems are meant to enhance and augment on-site security staff, not necessarily replace them. And a prominently displayed security solution with big cameras and barbed wire and so forth is an effective deterrent mechanism as well. So having it prominently displayed and showing that an area is secure can keep petty criminals from having any interest in really trying to do damage. And then because of the automated nature of many of the systems that we're going to be talking about, it really allows your security operators to focus on what's most important rather than staring at a video wall of hundreds of different cameras. They are always being alerted to what's the most imminent threat and what's the most deserving of their attention, and they can focus on coordinating a response rather than trying to pick out anomalies out of a large array of cameras. So just to put this a little bit into real world perspective, I'm sure most, if not all of you, are aware of the drone attack that happened in Saudi Arabia on an Aramco facility in 2019. This was a global headline news type of scenario that disrupted global oil supply chains and cost hundreds of $millions in damages and lost production potential. So, clearly being so critical to the global and the U.S. economy, the oil industry is always kind of under threat from bad actors. And you might be thinking that was Saudi Arabia, this is the U.S. It's kind of a turbulent region of the world, and things like that don't happen here. But we've actually got some precedent ourselves on home soil here in 2013 in a different industry. It was in the power utility sector, but there was a domestic terror attack on a substation in California called the Metcalf substation. It's a huge substation just outside the Bay Area that has millions of customers that are relying on the power there. And that attack was they don't really know much about it, unfortunately, because there was no security system in place. They never found the person or people that did it. It caused $15 million in direct damages and a month of downtime as a result of that substation going out. So that really drove an uptick in government regulation in the power utility space to increase security measures and better protect that really critical oil and gas space, because they're equally critical to the continuity of the U.S. economy. So really, while this was different, really we should be focused on ensuring nothing like that ever happens in the oil and gas space in the U.S. And then just a couple other threat profiles that we've been hearing about in the oil and gas industry. One is offshore piracy, or piracy at offshore facilities. Depends on the region of the world that you're in, but again, that's critical for the safety of employees and the continuity of supply chain there, to make sure that pirates can't be attacking offshore oil rigs. And then lastly, there have been reports of oil tankers coming into port being used for drug trafficking, particularly with drones. So a drone will be kind of perched on an oil tanker, and when it gets within range of the shore, take off and go land somewhere with contraband. So that kind of introduces this whole concept of an aerial threat to the oil and gas space as well. So FLIR is mostly known for thermal, but we actually do quite a bit more than just thermal. And 40% of FLIR's corporate revenue is non-thermal related. So what we're going to be talking about today is our security solutions, and that includes fixed thermal cameras, pan tilt zoom thermal cameras, visible cameras, radars, drone and counter drone systems, command and control software, video management systems, and advanced analytics solutions, both on device and server based. So when we talk about our perimeter security solutions, this is an idea of what it looks like. So we think of security in terms of concentric circles, and for those that are in the security industry, that's nothing new. But for those that aren't, the center circle is essentially the asset that you're trying to secure, and then each circle going outwards is another layer out in terms of range and detection warning, the number of seconds you get between when a threat is identified and when they're imminent. So the first layer here, I turn my laser pointer on, is the physical fence, and that is, I'd say we're going to say that's optional for this specific scenario, because when paired with our fixed thermal detection cameras, they can work both with a fence or without a fence, because you align them so that looking down the fence line, and at each of these corners you would install a camera looking down the length of the fence, and it would create a continuous virtual perimeter, call it a thermal fence. And these cameras have analytics on board, or a software algorithm that allows you to configure it specifically to your scene, and when somebody or when a threat approaches, the camera will alarm that something is off, that somebody has either crossed a tripwire, or they've entered a region they're not allowed to be in, or they've spent too much time loitering in a certain area. So this is your kind of, call it your last line of defense at the fence line. And because these cameras are looking down the fence line, you're really only getting, if somebody's running up to your fence, jumping over and running past, they might be in the frame for a few seconds. And so that's why you need the pan tilt zoom camera, because as soon as an alarm is generated by the fixed camera, the pan tilt zoom comes and looks where the threat is, and then either automatically or with operator intervention with a joystick, they'll take control of the camera and follow that threat around until they're apprehended. So you're never kind of wondering where that person might be in your facility. There's always a camera with eyes on them. And then the outermost concentric circle is radar, which is an optional layer to add to this whole system for early warning. And really early warning is what it boils down to. It allows you to look past your fence line and get an idea, especially in remote areas, that there might be a threat approaching. If you're in a remote area where you're not really expecting anybody ever, then essentially any radar track could be conceived to be a threat, and you'll be able to prepare a response team for when they actually do become an imminent threat. So it gives operators much more time to assess the situation and plan their response. So I drew up a little mock-up of what a perimeter security solution might look like at a relatively large refinery site here. This is just some generic site. And for those of you that have been in the security industry, this is going to be pretty, you're going to understand this picture. For those that aren't, it's a little bit overwhelming in terms of all the things you're looking at. But each of these little triangles, this is really just another way of showing what I showed in the slide previous, where each of these little numbered triangles is a fixed camera, and the field of view of the camera, which is what it sees, is a triangular shape, and you see them overlapping each other all the way around the perimeter continuously. I think it's a total of 40-something cameras. And then you don't need a one-to-one pairing of the PTZ cameras to the fixed cameras. So the PTZs are depicted here in these circles, and the reason it's a circle is because it can rotate 360 degrees, but really at any one time, it's only looking at this little green sliver here. So again, say camera 5 identifies a threat that's imminent in the perimeter. This pan tilt zoom camera will slew over and take a look at that threat. So that's what a site design looks like for a typical refinery. Now, it's almost a shame to be dumping this many cameras around a perimeter for the occasional case when something goes wrong, because in reality, you're hoping that really this doesn't get used that often, the security system. So we have some alternative applications for these systems that'll allow them to be in use in the 99% of the time when they're not actually actively assessing a security threat. So one of those alternative use cases is tank level monitoring. So the pan tilt zoom cameras that we were talking about previously, or the fixed cameras really, but those fixed ones tend to not have very much in the field of view besides the fence line, so they might not be as useful for doing alternate things. But the pan tilt zooms are always they're motorized, so they can look at whatever. And here's an example. If you look at this PTZ camera, you could be looking at this oil tank or really any of these. And we have a partner called Clean Connect that writes in a software algorithm for tank level monitoring, and you can assign, these are three different tanks: tank 5, tank 6, tank 7, and the algorithm will determine what the volume is inside those tanks. And at two different moments in time, as you can see here, the levels are completely different. So you can add some kind of business intelligence or operational information as an output of the security system, which again allows you to use these cameras while they're not actively assessing the threat. And the priority will always be a security threat. So if the PTZ is over here looking at the levels of these tanks, but then the fixed cameras on the perimeter determine that there's an intruder, it'll drop whatever it's doing and go and look at that intruder. So that's that's logic that can be easily programmed into the camera to make sure that important events are not missed when the cameras are off doing other things. Another example is FLIR stack monitoring. So this is, again, another way to reuse these PTZ cameras for operational data collection or just information that might be useful. It's important to note here with this audience that this is not optical gas imaging. It's not a radiometric camera that's determining the temperature of that flame or anything like that. It's just kind of an on-off determination of this FLIR stack is on, this FLIR stack is off, because the cameras used for security don't have the same level of sophistication in temperature measurement or in spectral filtering for different gases. So it's an alternate use, but it's not either of those other things. And then just before we hop back to the security use case, just a couple additional items that are kind of adjacent capabilities that we're talking about here. We've talked about fixed and PTZ security cameras. Also, we have a whole slew of products for condition monitoring, or another word for that is predictive maintenance, where if you have power transformers or large motor assemblies or pumps that are critical to the operation of your facility, and where an elevated temperature might be a sign that a component is giving out and that there might be a failure imminent. These condition monitoring cameras are great for catching that failure before it's too late and before it's actually failed, and allows you to predictively or preventatively maintain those devices. Optical gas imaging somewhat speaks for itself because it allows you to see gases that you can't see with the naked eye, such as hydrocarbons, sulfur hexafluoride, carbon monoxide, and dioxide. So there are various different cameras with capabilities to see these gases that are invisible to the naked eye, with obvious applications in the oil and gas space. And then the last two, furnace inspection cameras. These are used to understand the health of high temperature furnaces to make sure there's no failures within them. And then elevated skin temperature screening at your access control points, for human safety. All right, so now back to security. So in terms of how thermal can help you secure your perimeter, it's different from visible light cameras in a few distinct ways. One of the most important is that it's a 24/7 detector that doesn't rely on you building out a complicated and expensive illumination solution. These cameras work 24/7, and they'll detect intruders without even starlight. So you don't need any light at all. Every object, definitely every threat in the known universe outputs heat, and these thermal cameras are able to see those differences in heat and temperature. So it's not like the sun is reflecting off of something and then the camera is detecting that. It's actually detecting the infrared energy coming straight off of the target itself. An additional benefit of thermal in security is that it has high resistance to image degradation in poor environmental conditions. So whereas a visible camera gets completely rendered useless in foggy or rainy conditions or snow, or in sun glare, thermal does a much better job. Still in thick fog, it's going to be difficult even with a thermal camera, but in light fog, in rainy conditions, and again with sun glares and so forth, it's relatively unaffected in terms of its performance in identifying threats. And then because humans and vehicles generally run hotter than the backgrounds that they're in, not in all cases, but in many cases, that provides really good contrast for software algorithms to be able to pick up those targets in the scene and provide automatic alarms. So we call that video analytics. Thermal is really well cut out for high accuracy video analytics. So this is an example of one of those situations where a human stands out really nicely in thermal, where you can't see them at all invisible. So in that thick brush, with a visible camera, you'd have no idea that there's a human standing there, but in thermal, it's couldn't be more obvious. And here are a couple videos of our video analytics at work. So you can see here, this human has been detected. There's a black box around them. Now that box has turned white, which means that an alarm was generated, and that H next to him stands for human. So that's a classification that the threat is a human. The same can happen for vehicles in the case that it's a vehicle detection. And so the camera was calibrated to have this this whole area here that's about to light up white again be the region of interest. So as soon as the person walks into that region of interest, it generates an alarm. So you have the ability in the camera to, say there was a busy road, off here in the distance or something, you can ignore that by just calibrating the camera for that purpose. This video is of the auto tracking. So again, left side is the fixed camera that just made a human classification. The right side, you saw it was a pan tilt zoom camera. It happened quickly, but it was off looking at something else, potentially monitoring the level of some of your storage tanks. And as soon as the alarm was sent by the fixed camera, the PTZ came over, accepted that track, and in an automated fashion is now tracking that target around your facility. And you can see, the person is no longer in the fixed field of view. It's entirely happening off of the PTZ camera. So all the tracking is happening based on the image on the right. And you'll see he's about to walk back into the image on the left, but that doesn't matter anymore. It's auto tracking based on the image on the right. So that kind of gives a high level overview of our thermal cameras and some of our video analytics. Next, I'm going to talk about radar technology, which it's kind of up and coming in the security industry, as it's a military technology that has been around forever, but it's becoming more and more affordable, and in the security space has a lot of advantages, because particularly if you're familiar with cameras, long range is equivalent to a narrow field of view. So if you need long range, you can only look through a little sliver in space. But with radar, it gives the advantage of both long range and 360-degree coverage, or in some cases, 90-degree coverage. And you can pair multiple radars together. So you can get the advantages of long range detection without having to sacrifice on coverage area. And so radar tracks are generally displayed on a map. So that gives you even really nice situational awareness, especially in a large facility where a bird's eye view of a map is really much more effective for understanding where a threat might be. And so this is what our lineup of radars looks like. And you can see here a really common pairing, which is a radar with a pan tilt zoom long range camera, because a radar only gives you an idea that there is something there, and it provides some classification, but it doesn't give you any visual verification of that. So I'll show a video coming up here of how nicely the radar and the camera interact with each other and provide really great situational awareness over a long range and large area. So you can see these are maximum detection ranges from 700 meters all the way out to 30, 60 kilometers, depending. Really, at that point, you're just dependent on the terrain. So for coastal or for very flat desert environments, you can get up to those ranges. Radars are line of sight sensors. So if it's a hilly topography, they're going to have a lot of blind spots. But for flat, wide open area, radar is really well suited. So this video that I'm showing here is through our Chameleon command and control interface software. You've got two cameras, both showing their visible stream, but they're actually both bispectral cameras. And those cameras with the live video are these two kind of off-white cones here. And you can see that there's a radar icon here spinning that's making these detections. That right there is a radar detection. And the cameras can be programmed to automatically point at those targets. So just now the operator was kind of clicking around manually, but now we're in automatic track mode. So this yellow target here is this ferry coming across Vancouver Harbor. and the camera is automatically acquiring and tracking that based on the radar picking up the signal. And these different colored zones designate different priorities. So this red area is a priority zone. If anything goes into that priority zone, it automatically becomes top priority, and the camera that's assigned to it will look there, drop whatever it's doing and look there. Whereas these other zones are set up for lower priorities. And there's also the ability in this Chameleon software to right click on a target and mark that target as either a friend or a foe. So if you have, a patrol vehicle, for example, you can mark that as a friendly and ignore it on the camera will ignore it. It won't ever look at it. And the same goes for a foe. You can prioritize a target by marking them as such. So Chameleon is a really powerful piece of software, and I'm going to talk a little bit more about it because it's the basis for our drone detection solution. And so what I showed there already is kind of how the radar and PTZ cameras interact with each other. But there's a lot more that Chameleon can do. It's not a video management system per se, but it interacts really nicely with leading video management systems out there, like our Latitude VMS, like Genetec and Milestone. But Chameleon allows you to pull in a lot more disparate systems that a VMS can't support. So access control, intrusion systems, license plate systems, buried fence shakers, lighting, even variable message signs. So things that go above and beyond the scope of a video management system can all be pulled into Chameleon. And there are numerous ways in which Chameleon can interact with the VMS. It can, overlay on top of it. It can slot in underneath it and just supply live video and alarms to that VMS. And really, I don't want to spend too much more time on this topic, but if you have any questions about Chameleon and how it might interact with your VMS, let's definitely have a conversation afterwards. So I'm going to wrap up the presentation here with our drone detection capabilities, and this is becoming a bigger and bigger problem, a threat profile to security directors around the world. And for obvious reasons, it's adding a third dimension to your threat profile. You have to now worry about the sky. Drones are tiny and they move very fast, so it's difficult. Really, there isn't a single sensor out there that's able to detect, classify a drone, keep an eye on it, and do so reliably at range. So the challenge of detecting drones accurately requires a layering of different technologies. So I've talked about Chameleon being at the center of that, and that's really because we're having to layer these different technologies with each other. So Chameleon brings all the information together. The detection of a drone is done by radar. So these are specific radars that are calibrated for three-dimensional space. They can see airborne targets, and they can classify things that are tiny, like a drone, up to a couple kilometers. Then once the radar has found the drone, it provides the GPS coordinates for a camera to come over and assess it. And really, that's because the radar isn't able to keep track of a drone accurately enough with the refresh rate and the positional accuracy required to track a drone. So what happens is it hands off to a camera one time, and then the camera uses onboard intelligence to lock onto that target and start tracking it around. And also do a classification, because it's difficult to get an accurate classification of a drone from only radar data. So the camera layer is for, again, classification and tracking. And then you get to what you do about the drone once you know you have a drone in your area. And that becomes complicated from a just regulatory standpoint, because right now in the US, drones are considered aircraft, and you can't shoot one out of the sky, obviously. But so the best mitigation method you have right now is to go and essentially apprehend the pilot of the drone. So we have a partner called Dedrone that builds an RF radio frequency detection technology that can triangulate the location of the operator of the drone. So if somebody's manually flying this with a remote control, drone will tell you where that person is, and you can go send somebody after them to ask them to take it down or whatever your response is. The challenge there is that it only works if the drone is being flown by a remote control. And we know from some of the more nefarious attacks that a drone can be pre-programmed to a certain GPS position and then just told to fly there. And in that case, the RF detection won't catch it. So that's why you need these additional layers to catch a drone that's flying by GPS coordinates. And then in closing here, we've got a couple videos of this at work. So this is what the 4-panel array looks like to get 360-degree radar coverage. And then the paired camera, this is a pretty long-range camera to be able to detect the drone at long range. So these are working together in real time at our test site in Victoria, British Columbia, at the airport there. So on the left side, we've got the radar detection of a drone, and then in visible and in thermal video, that drone flying. This is a DJI drone. And you could see it was floating around a little bit, and that's because the radar provides the location of the track within a certain error. So it was floating around a little bit, but it was sufficient for the camera to then lock on and acquire it. So this next video shows what it looks like when the onboard intelligence classifies the drone as an aircraft. This little pixelated zoomed in view is sometimes helpful, sometimes not as much, but it allows you to get a better understanding of what that drone looks like or what the target looks like. And here, the PTZ camera is actually moving to keep the drone in the center of the field of view. And that's it. Any questions on what I just showed you? I know it's a kind of a broad strokes overview, but I'd be happy to dive further into anything that you guys are interested in.
Anybody have a question? We had a question. Where do you see the regulatory roadmap going in terms of the counter USA?
It's a good question. I mean, I think the FAA hasn't, to my knowledge, released their roadmap on what they're going to do about drones, but it's becoming enough of a problem that they're going to have no choice but to address it. I can't speculate as to which direction that's going to go. It's a very complicated issue, especially as you can imagine at an airport where you have planes around. Got to be very cognizant of not unintentionally damaging anything that's not a drone. So it's a very difficult problem, but I've got to assume that the FAA is going to get on top of it sooner rather than later. And we've been hearing from many of our customers that they want to start understanding the landscape of drone detection technologies and what their options are for when the regulation does open up, rather than waiting until that time to understand what their options are. So it is something we're seeing growing demand for, even if it's just at the proof of concept stage in many cases.
Thank you for that. Anyone else have any more questions? We also have Craig, if you guys have any questions about the FLIR camera as well.
Yeah, and I mean, I've got my contact email up here. If you have anything that comes to mind after the fact, feel free to reach out. Be more than happy to answer any specific questions later.
Where do you see the regulatory map going?
Is that the same question as previous, or is there a different spin on that one?
Previous.
Yeah, so I can't really speculate exactly what the FAA's direction will be, but I've based on what I'm hearing from customers and the growing threat profile of drones, they're going to have to address it in the near future.
Okay. Anyone else have any questions? Well, then with that, we will conclude today's webinar. Kai, thank you so much for today's presentation. It's been very informative. We will be posting this on our YouTube channel, so if you have any questions, please feel free to email Kai directly. And thank you everybody for attending today. We appreciate it. Thank you, Kai. Thank you, Craig. Thank you, Teledyne FLIR. And we look forward to seeing you at the 4C conference, August 18th through 20th in Hilton.
Thanks for putting it on.
Thank
Thanks
you
everyone
so
for your time.
much.
Have a good day.